Well, hi, good morning. Thank you for joining me in my shop. It's January 15th, and you may have heard me over the last few weeks kind of, for some strange reason, complaining about lack of snow and it's not that cold. Oh, well, that's over. That's over. There's a couple of feet of snow outside, and it's minus 15 this morning. And it's going to stay cold for the rest of January, I imagine. So, okay, winter has finally arrived here. Okay, what am I going to do with this radio? So it appears to have a defective electronic vibrator here. I can only say appears because in my mind I have not absolutely proven that's really the problem. So I don't know what to do about it at this point, so I'm going to do something else. I'm going to try to operate the radio without the vibrator there, or the electronic D to A converter, direct current to alternating current converter is kind of what that is. So I'm going to yank this out, and I think that's going to disable the power supply function, if you like, in such a way that I'll be able to place my own couple hundred volts into the radio in replacement of this, and operate the radio, find out about the rest of the radio, find out if it's working and all that kind of stuff. We still have to heat the heaters, so we need to look at the schematic and figure out if I apply the 6 volts, will the heaters come on, will the 6 volts go somewhere I don't want it to go, and where should I place the high voltage input for my high voltage power supply. It's this guy up here. This is the high voltage power supply. And what voltage should I use? So let's take a look at the schematic. We'll sort these questions out. Okay, here's the schematic. So first question is, what if I feed power in here, but I have this pulled out? So we power goes this way to feed the tube heaters. That's fine. What about this way? It would enter into this coil, but when it came out here, it would meet a dead end. Likewise here. So I think it's pretty safe to say if I pull this out, no power travels down this line. And I think I know that already because didn't I not pull this out and then apply power and saw that there was no short circuit. Put this back in, apply power, you find a short circuit, which I believe is inside this device. Okay. Next question is, so what is the voltage? Got to be somewhere between 200 and 300 volts, I would imagine. So the messy AC that this guy's produced comes out here, gets transformed up to a higher voltage. Exactly what they're doing here, I don't know. But out of the center tap comes high voltage. Reaches the filter capacitors. This is a very small, this is probably a high voltage capacitor here. It says 15, 30, and 30. What are these numbers? 20 and 20. And very small. 200. 20, 20.0. I don't know what these numbers are. Well, they are voltages, I'm pretty sure of that. Let's follow this line, we'll see where it goes. This one looks like it's heading for the output tube, so that'd be a good one to follow. Follow it up. Okay, we get to here, it goes into the center tap. Comes out here to the plate. There's a voltage right there. 242. 242 volts. So that's coming down this line as opposed to this one. This is a less filtered supply here. Where these lines cross, they are not connected. they're connected. The draftsperson's used a dot, but he used a very small dot. Can't even see the dot there, but here it's just crossing. There's no connection there, so I think that's what's going on here. So we have I don't know what's happening right there. Hard to tell if there's a dot there or not, but there must be some kind of large-scale filtering going on. So there's a 20 here, looks like. What's the 30? 20? I don't get it. 15, 30, 30. I don't get it. Okay. So there's probably a higher, maybe a higher voltage. How can there be a higher voltage here? There's a resistor right there dropping it. So the 242 is probably a little lower than what's actually getting to the plate, and I'll bet you that's the number right there. And good grief, we can't read that. So somewhere around 250 volts here. Now if I put 250 volts here, what's it going to do with this transformer? It's going to go through it and reach this capacitor. Same thing down here. So there'll be no current flow. And then it could go out here, but this is pulled out. Will be pulled out, so there's nowhere for it to go. So it looks perfectly, same thing here, perfectly safe to me. That I can, well, I can power this radio up without this unit plugged in. Feed in feed in the 6 volts here to run the heaters, and feed 250. Over here, and we're in business. The radio should operate. Okay, we can try that. Okay, we're ready for a try. So this will be the B plus power coming down from the power supply up there, and we need to put the negative to ground, which can be anywhere. That's good. Here's a braid I can clip onto. And now this needs to go on the positive lead, one or the other of this capacitor. Now there's a resistor here. I think I remember seeing on the schematic. Let's just take a look at this resistor. It's a brown, gray, red. What would that be? 1, 8, looks like 1800, something like that, sitting here. And this could have been replaced, this particular one. I don't think so, actually. Just looking at the way it's soldered, it's probably original. So 1800 capacitor or resistor off of one of these lines, just to kind of get a feel for where I am in the radio. Okay, so there we are, 1800 right there. This must be a part number 45. I think that's what these are, 27. And the reason they've duplicated them here, a 30 and a 30, because it's the same value of part. So probably you were yelling that at me while I was looking at this earlier. Okay, so 1800. So if we hook up on the 1800, on the capacitor end of the 1800, we're supplying this line. We can't see for sure that this is connected. I mean, it has to be connected. If there's no connection here, there's no positive supply heading up into the radio. I could clip here. This is the non-resistored capacitor leg. I don't think it makes much difference. Looks like they're just connected right together. That also doesn't make a lot of sense. If these were so look, so this and this are okay, let's look at it this way. This one and this one are connected up here. They are separated by this resistor. This one is a separate oh. Hey, what's going on here? There's no connection here, and there is a connection there. guess. Right, this is a push-pull output here. I kind of forgot that. Not that it matters that much right now. So we have a screen supply. Screen. These tubes are shown upside down from the normal view, so the heater cathode up here and the plate down here. I guess that means the electrons are falling down through the tube. Where's this one showing the same way? They're all showing what we would consider upside down these days. All the tubes. Okay. So we follow the screen line up to what is going on right in here. So we have something a little odd going on here. Oh my, what's it doing? Going out to here. Okay, so I have no clue what they're doing here, but they're doing something with the screen. Does that say screen? Or is it a G? Grid? I'm not even sure what I'm seeing there. Grid. Screen. Screen. Screen grid here. There's the voltage again, 242. There's the plate voltage, looks like 270 something to me. Heater input. Okay, well I think I'm quite comfortable with, connecting right here. All the high voltage coming out of the power supply must pass this point. So I'm going to feed in here, and as I analyzed earlier, the power can't go anywhere in reverse. Can't reverse out, unless we're looking at defective capacitors here, which I doubt very, very much, because we saw them. They look to be in good shape. So we're going to go here. This is the non-resistored lead. Oh, that's a tiny little capacitor. Take that back. Then I think we'll go here. We'll go here where the resistor is, and we'll feed in the power. Doesn't make any difference here or here. That's my conclusion. Okay, enough looking at this. Okay, we're going to connect the positive lead from the power supply to the resistored one. That's right here. Now my power supply up there has a couple meters on it. It has a voltmeter. Sorry, current meter and a voltmeter. And neither are terribly accurate. So instead of relying on this voltmeter, I'm going to rely on this voltmeter. Whoops, this one down here, which will show me the B plus voltage. And now I'm going to set this to 300 volts and positive. Now this one is still going to show the supply voltage coming from the big power supply. So this should say 6 volts. We shouldn't need to pay much attention to this. It's all about this. I have it on the 300 volt scale, which puts 150 straight up, 200, 250. So we eventually will get up into this range here to supply the proper voltage to the radio. But even at 150, it's probably going to work. What I'll do is I'll turn on the current to heat the tubes. We'll see this come up to 6 volts. And when I'm feeling sure of myself, I will then turn on, actually I turn this on right now, put it on standby, turn this down. That's a variable supply, so I'll be able to crank it up slowly. As for the radio, I have an antenna plugged in. The antenna is switched on also, which is a good thing. So there should be a strong antenna signal coming into the radio. We have a volume here, tone and tuning. So I want to tune the radio at the low end here, because there are stations down here. That's 55, 60 in the middle. So right in this area, should be able to find a station. This is a little, I wish I had a knob handy to go on there, but I don't think I do. just have to go with it. Okay. So, step 1. Turn on the big power supply. Watch this come up to 6 volts. And then I'll turn this on. Okay, here we go. Power supply. Wow, got my sweater caught on the knob there. Almost pulled the whole works off. My nice Christmas sweater. We got 6 volts. Gotta turn this on. We will heat the tubes up. So we're gonna, before we do that, we're gonna check and make sure this is working properly. So I'm going to, you can't watch this. I'm going to flip over to on, and now I'm gonna advance the B plus, and we should see this meter go up, and it should match the other meter. So that's 100 volts. This meter says, well, it says 75, so that shows you this meter is reliable, the other one is not. Okay, back down on the B plus, everything's ready to go. Okay, we're going to turn this on. Wait a minute, that's not supposed to happen. Oh, what happened to the voltage here? I wasn't watching. That's okay. Huh. Must be the alarm on that power supply is set. It's just below the 6 volt range. 6 volts on there. You can also see that there's a current draw, if you can see it, in this meter here, of about, let me just make sure I'm reading it properly, about 2 amps, if even that. About 2 amps. So each tube is going to draw 1/3 of an amp or so through the heater. 250 milliamps maybe. 1, 2, 3, 4, 5, 6, 7 tubes. So the output tubes probably draw a little more. Yeah, that's in the right range. Okay, so we can assume. Oh, look at this too. I didn't notice. The light has come on. The light has come on. Oh, that's good. Now we're not going to hear anything out of the radio till we put some B plus on it. So now we're going to turn this up a bit. We're going to start applying B plus. We're going to get rapidly up to the 150 range. Okay, here we go. So my hands on the control here. I'm also watching the milliamp drain on this high voltage power supply.
Travel through town. Your sign, it says $19.99 for all you can eat boneless chicken. Why, prices haven't been that low since dinners were popular. We're rolling back the price on our all-you-can-eat boneless chicken to just $19.99. Just a way of fighting chickenflation. Well, that seems more plausible than time travel.
Yep.
St. Louis Bar and Grill. Devilishly good since 1992. Dining only, limited time, taxes extra. It's your business.
We're probably on 590, and it's right in the right spot.
Make it grow. There's now. Sports and Media Ad Manager. Promote your business with Rogers Sports and Media, Canada's most beloved sports news and
We can go a little higher with the B plus here.
is self-serve and simple. We'll even give you a $250 ad credit to build your first campaign today. Visit grow.rogersportsandmedia.com to claim your ad credit. That's grow.rogersportsandmedia.com.
All right, guys, it's been a blast, but I gotta head out. Hey, Julie, you need a ride?
Thanks, John, but there's a reason I'm not driving, and I don't think you should be either.
Yeah, if she wanted to ride with someone who'd been drinking, she'd drive herself.
John, my sister's coming to get me. We'll drop you off. When a drinking driver crashes, passengers in the vehicle share the same fate. In a 2010...
Yeah. Don't drive your car when you're drunk. Okay. Well, I don't know what to do next. So, radio's operating. If we could get past the power supply problem, which is almost certainly a defective guy here, I think we're back to this. We're back to just trying to figure out if this is good or not. Obviously, one way order another one, stick it in. I don't think these are terribly expensive, but I'm not sure. And I assume they're still available. For all I know, they're not even available anymore. I don't know. I haven't looked. Somebody's got to be making these things, I would think. Okay, let me turn the power off. First, the B plus we'll take away. Then we'll take away the heater power here. There we go. Well, that's pretty good. Really, the only next thing I can do is get back to trying to prove that this guy's defective. How am I going to do that? I'm going to stop and think about it. I've almost proven it, even now, but it's still just a bit of a question mark to me. Okay, so thinking about this a little bit, all the things I've done here and what it all adds up to. The most interesting observation is just now when I tried to operate the radio with nothing more than the heaters connected with this out. And I turned on my power supply, it went into overload mode right away. Overload mode. Made all that beeping and then there's no power coming over because the power supply is smart enough to shut itself off. So that was without this guy plugged in. Now earlier I had this plugged in, too much for the power supply. Pulled this out, power supply seemed happy. Obviously this or something connected to this is causing the power supply to be unhappy. Also noticed the supply voltage fell from 6 volts to nothing. I misinterpreted that as indicating a short in the radio. Probably what it was really indicating was the power supply was overtaxed and shut itself off. And that's why the 6 volts dropped to nothing. So what it looks like to me now is if I had a power supply that could put more oomph out, it might get past this initial stage where the tubes draw a lot of current. Tubes draw a lot of current because they're not hot. Wow, could I fire up the radio, not have this external supply? I don't want this connected anymore. In fact, let's just turn it right off and take it right off. So I'd heat up the tubes. The tube current draw would be low. Radio would be operating without this. Well, it wouldn't be operating, but it would be switched on without this. And then plug this in with the current supplied to the tubes. In the course of plugging this in, I would engage the rest of the high voltage system. The current draw on the high voltage side is very low. We actually saw it. I actually saw it on this meter, and it was in the range of 15 to 20 milliamps, as opposed to some amps, couple amps. Another strange thing is if the tubes draw a lot of current at the start, to affect my power supply over there, they got to draw more than 30 amps. The power supply can put out 30 amps. Why is it doing what it's doing? How does it think there's 30 amps worth of load here at any point? They can't. Could it? Unfortunately, I cannot turn the power supply any lower than it is now. Just a little bit lower. Maybe 5.9 volts. If I could turn it lower, then I could stop any rush of current, whatever that might be. Keep it within the range of the supply. Once again, I really have big question marks over whether this is defective, or whether I've been completely fooled along the way here. Completely fooled. That's probably what's happened. So how to approach this? Do I dare try plugging this in with the radio operating, with power to the radio? Again, the idea is power supply supplying the tube heaters, fine. This goes in. At that point, a short circuit appears and the power supply goes away. Or I get past this bench problem I'm having that I'm considering right now, and bingo, the radio starts operating. Now the radio was brought to me because it stopped operating. I've demonstrated that given a operating power supply, it will operate. Do I dare plug this in with the radio operating? What could go wrong? Partial contacts causing weird voltages of some sort. Who knows what? I don't know. Pushing this in is difficult. It's awkward. You have to get this bump past the grip fingers, and it's not easy. I'd have to be pretty rugged and get it in there pretty quick. At the same time, while my hands are all over this radio, the moment it goes in, what could happen? The power supply might quit, like it's done before. So what's a big deal there? There is no big deal. Power supply drops to zero because there's a short, or this plugging this in connects a short in. I don't know how else to I don't know, well, what else could I do? I mean, what else can I do? I can practice putting this in. I can practice putting it in and taking it out. Putting it in is the main thing. Let's see what happens. So I have the radio sitting just like this. Oh, which way does this go? This way or that way? It goes in this way. Okay, if I come around like this, what I would want to do is have it ready to go. So I'd want it in the grips a little bit. Without the prongs going in. Oh man, this sweater gets caught on everything. And so the problem is the getting the prongs lined up is a bit of a challenge. And I have to hold on to this radio. This thing's operating. As soon as I push this in, high voltage is going to appear on the radio. I should turn the volume down. For sure, it's off right now anyway. Pushing this in is just, I don't know, all my safety alarms are going off here. It's very hard to push it in. I can't, you know what, I cannot see if I have the pins lined up, so let's solve that. See, it's a good thing I'm practicing this because I wouldn't want to do this just get one pin just started. Wow. Actually quite troublesome here. So, I have hooks and nails sticking out all over the place, and it keeps catching my my Christmas sweater. Can't do this from here at all. The thing about the Christmas sweater is if I hook the wrong thing, I'm going to pull a pile of stuff down. Caution is required. Okay, so I think the pins are lined up. Can I just push it in a little bit? Not really. See where my fingers are going here? No, you can't. So and push them like this, I could just see myself eventually getting into contact with the high voltage here. It shouldn't be there until I push this thing in. Plus, you know what? My hand's on the chassis, my other hand's all over this thing. I'm really setting myself up for a bad shock here. I think that's really where I'm going with this. I don't like it. Okay, there's another way. Another way. How could I have the vibrator plugged in but disabled? Maybe by removing one wire here or something like that. Operate the set and then connect the wire to connect the thing. I don't know about that. I don't know about that. I don't know about that. Yeah, I don't like the idea of pushing it in with the set operating. So what I'm really trying to get around here is, am I being fooled by the startup draw current on the cold tubes? It's making me think there's a short circuit in here when there really isn't. And I've just been fooled. The series of tests I've done have just been confirming my foolishness. So we've operated the set without the vibrator, got the overload situation. Once the overload happens, the supply cuts, and you're not going to heat the tubes up and escape it. I can heat up the tubes, cut the power, shove the thing in, hit the power before the tubes cool right down. Tubes do take a little bit of time to cool off. Probably got about 10 seconds in there. Okay, on the cutting the power off from the vibrator here, and that's not impossible to do. A little bit of finagling. I'd have to look on the schematic and find that split where the power, one leg goes to the tube heaters, the other one goes the other way. Find that, cut the wire, and then arrange a switch or do this kind of thing. That's pretty awkward too. So I'm going to try to the one that's least, the one that's least. Operate the radio without the vibrator, heat the tubes up, cut the power, shove the vibrator in, turn the power back on, see if the radio operates. To do that, I've got to move this camera out of the way, or I'm going to for sure stumble all over it. Go like this. I'm still going to get in the way here. Excuse me. How can I get this camera out of the way? Okay, let's try something a little different with the camera. I've never stuck it. Okay, you're going down. Going down. Okay, now up here. Have it sit here. Okay, it's way out of my way now. Yeah, the full range of my shop. So what I'm anticipating is I'm going to reach over like this to hit that power supply. Maybe I can do something a little different. I can have the power supply on, plug the plug into the power supply. Which is just a little easier to do. Okay, so I'm going to pull one lead out of the power supply. I'm going to switch it on. Okay, and we're going to put this back on. This guy, we're not paying any attention to him. Not connected to anything. Go away. Okay, so plug in, warm up, pull the wire, shove the thing in, stick the wire back in. Does the power supply survive? You'll be able to see it on here if it survives. Switch on. Okay, I'm now going to plug in. When I say plug in, what I'm doing here is just a second here. You can see the connectors pulled out. So I'm just going to plug that connector in. That'll send 6 volts at the radio. So 6 volts at the radio. Why am I being so careful? Okay, interestingly enough, I saw the current meter go right up to 10. Could it have gone, before it went far enough to trigger the, stop mumbling. Okay, we're going to give the tubes a moment to warm up. Won't take long. We also know from the radio test and the radio operating that all the tubes are operating. So, looks like it's drawing about, again, a little over 2 amps on that meter, but it's not very accurate. Our voltage is 6, exactly 6. Okay, so I'm going to cut the power, jam that thing in, wow, and then turn the power back on. If it takes longer than 10 seconds, probably a false test. Okay, you ready? Am I ready? Oh, you just turn it off here. Even better. Turn it off here. Plug that thing in. Plug that baby in. And the time is up. I was not ready. Wow, this is just about impossible. Okay, so first attempt failed, but yeah, still 6 volts because there's 6 volts supplied, but the switch is open now. Let's just get this guy half in. Oh my gosh. This is fun. Oh my gosh. Oh man. Probably swelled this out a bit when I did the, yeah, for sure. Bigger than ever. I don't see any particular bump on it though. No particular bump in the way. It's clearly a test of my manhood, my muscular power here. I'm failing the test. Am I really lining this up? It's lined right up. Come on. Oh my gosh. Oh, that didn't sound good. Once again, am I doing this right? I'm sure I'm doing it right. Yes. Obviously, there's no real easy way to do this. I've got this coin on the floor. 2000 something. Where did this come from? Some kind of remnant. I think it might be Chinese. This might be Chinese money. Year looks like the year 2000. It's a 1. Yeah, it's Chinese. Huh. I don't know. Can I actually show this? I don't know. See the Chinese writing. Somehow I got a Chinese 1 coin. But, nice distraction, but it's not going to help the situation any. Okay, different approach. Different approach. Just to be sure, I'm going to pull one lead out over here. I'm going to shove this thing in somehow. And we're just going to start the radio up again. Just see what happens, because oh my gosh, I'd have to put the radio down and put my weight right into it to get this to go. Oh my gosh. Magnet's causing me some headaches here. Oh my gosh, what a schmozzle. What am I pushing on now? Pushing right on the volume control piece here. Don't want that. See, a lot of these things, you can line up the pins before the gripping starts. So you get the pins lined up and then you push it down and then the gripping starts. But this thing, the gripping is starting before the pins line up, which means I have to be shoving hard while yeah, I got it in that time. No, that went pretty good. That went pretty good, actually. Okay, it's in. I'm going to tip it back up. Basically what we're going to do is just going to repeat the hello there, hello everybody. Why don't you leave it down? Once it's down, you leave it down. Once it's down, leave it down. Oh my gosh. Okay, I still have the 6-volt meter connected. Or do I? I bet you I don't anymore because I pulled this out. Uh-oh. Okay, somehow I got the radio right on top of this. Oh my gosh. Calm down. Calm down. Caught in the rollers under here. Okay, right. No 6-volt meter hooked up. Let's hook it up. Get to the ground. Go right here. Okay, 6-volt meter hooked up again. Vibrator in, repeating the test. There we go. First, supply the power. Turn it on, and I have a feeling this is going to go to 0. There we go. Let's try it again. One more time. Can I pull this out, pull out the vibrator enough, maybe pulling out enough to disconnect it from down here? Fat chance on that. It's all out or all in. That's how this thing seems to be. Let's go back, 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 back. It came right out. Okay. Let's try this again. Okay, we're going to switch on. Let her heat up. you know, to some degree, what I'm trying to do here is defeat the protection on my power supply. somebody could ask some questions about the wisdom of that. Okay, so we're going to shut the set off, jam that thing in like gangbusters. How am I going to do that? How am I ever going to do that? I'm just going to really manhandle it in. Okay, here we go. Switch off. Get in there. Okay, it's in. Switch on. Ho 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 ho. Okay, it worked. Sort of.
Hello, boyfriend's new girl.
More than sort of.
Changed when she traveled south. What turns that?
Hear the buzz? Gee, this capacitor's not doing its thing.
Professional. Air Transat. Travel moves us.
Supply voltage is down.
Winter has a habit of sneaking up on us. The slow shift to cold, the frost creeping closer, the chill that comes out of nowhere.
Current draw is
Winter in Alexis, with
quite a bit.
all-wheel drive and an intuitive safety system, you'll take on the winter roads with confidence.
6 amps.
Stay warm while keeping cool this winter with heated and ventilated seats standard in every Lexus RX. For details, visit your local Lexus dealer or lexusontario.ca. There's Victor.
Okay. What do we make of that? I'm going to have a little coffee and think about what just happened here. There's a lot here to think about. Yeah, I just wanted to share something, nothing to do with this radio. Just watched a video yesterday, and a little bit of information I'd love to share with you. Do you remember back in 1978, this super fast computer came on the market called a Cray computer, and it was the be-all and end-all. Super fast, huge memory, fantastic capability, light years ahead of everything else. About the size of a say like a large refrigerator, something like that. Kind of a funny round shape. It's kind of cool looking. I remember it. I remember it coming out, and just blazingly fast. This cell phone, just ordinary cell phone, 100,000 times faster. 60,000 times as much memory in my little tiny hand here. I thought you'd get a kick out of that. I certainly got a kick out of it. 40 years to do that. Okay, back to what I'm going to do with this radio. What am I going to do with it? I'm going to go drink coffee. Okay, gave it a little bit of thought, and I think what I'm going to do is I'm going to stop for today, as I have some other matters I have to deal with. So, good show. I got myself past a false notion. So now it looks like the vibrator works, and the problem really lies further in the radio with probably the filter and probably this capacitor hanging here. It's probably what it is, but we're going to find out tomorrow. So thanks a lot for watching, and have a great day.